Next thing we're going to look at is what's called the intersection of two sets. And here we're still talking within the context of universal sets, but for this stuff we actually don't need that quite as much. The idea here is that for sets A and B, their intersection is exactly what you'd guess based on that name. It's the collection of elements in both, and it's denoted A, and I call the symbol cap. It looks like a little bump like that, or like a very large lowercase n, but it is A intersect B, where, if we want to think about this in terms of set builder notation, we say that A intersect B is equal to the set of elements X, such that X is in A and X is in B. You can think of the intersection as being something that says both, or you can think of it being something that says and, because it has to happen in both. It has to be in one and the other. And to think back in terms of Venn diagrams, this would be something like what we were seeing in that case of overlapping stuff, where it's just that little region in the middle that has a touch of both. So let's take a shot at a quick string of examples. Let's say we've got a bunch of sets here. Let's say we have sets A equals 1, 2, 3, 4. B is the set 3, 4, 5. C is set 5, 6, 7. And finally, D is the empty set, which you can denote either with the line or the empty brackets. The long and short of it is D is empty here. And our goal is to find a bunch of intersections using these pieces. So first, we're going to look at A intersect B. Looking at A intersect B, what we want to find are the elements that are in both A and B. Double check my notes, make sure I'm telling you guys to look for the right thing. Yep. So here, not too hard, just 3 and 4. Similarly, if we look for A and C, what we should notice here is that A and C don't share anything. And if you end up with looking at the intersection where things don't share any elements, you always get stuck with the empty set. And this is actually something that happens twice here, because technically the empty set doesn't have anything in it. So it can't share elements with A, which means that the intersection of the empty set with A is also empty. And this is important for us, because it points to a general rule that makes sense if you think about it. If you intersect any set with the empty set, you always get nothing, because the only thing that is in both anything and nothing is nothing.